I'm gonna use the lapel mic. So this one's on, but I'll turn that off after I get there. That's fine, no problem.
Welcome everyone to Math Day. This is the moment you've been waiting for all this time. It is finally here. We're here for Math Day. Maybe you didn't know, but Math Day started around 40 years ago. Math Day has been a tradition here for many years. And we also sometimes don't think about the many students that come before us that walked the AMU, that walked Old Main many, many years before us, the students, before the faculty. There's been a long tradition of things happening here at the university. And in fact, today we're very, very excited to bring back one of our students, Dr. Gary Herman. Dr. Gary Herman holds not one, but 3 degrees from the University of Findlay. So let's see, he holds a Bachelor's of Science in Computer Science and Mathematics Education, a Master of Arts in Educational Leadership and Administration, and a Doctor of Education. He has also been in Paulding High School, Van Wert High School. He's been a curriculum coordinator for Putnam County Educational Service Center, and we're very fortunate that recently he has come to the University of Findlay and is now an assistant professor of education. So let's welcome Dr. Gary Herman.
I think this one's on. I don't want to get any interference here. Well, thank you for inviting me back to the University of Findlay. Happy Math Day to everyone. I actually broke out my old math tie from teaching and my math socks from teaching for today. So as Dr. Bukowski said, this is a truly special place for me. As he said, I was in your shoes as math students and as a math and computer science major here at the university. So I feel like it wasn't that long ago, but to date myself, the fall of '96 was my freshman year. So I did graduate from Findlay in 2000, so I at least say I can graduated this century here at Findlay. But this place has always been held a meaningful spot in my heart. Throughout my degrees, it's been 30 years on and off that I've been a student here, and now I've come back to teach in the College of Education, and so I have really enjoyed the experience I've had here. But today, I may be at the podium some, but I don't like to stand there all the time. But with the 2 different speeches, I don't want to make sure I get things confused. I was talking to Dr. Roll. I do want to give a shout out to Dr. Roll. She was my advisor and kind of set me on the path I was in here. So a huge shout out to all of her support during my 4 years here at the university. But what I'm here today to talk about is artificial intelligence. And artificial intelligence really has become nearly ubiquitous in our society and being embedded in all of our devices and platforms that we use. And really what I want to talk about today is that it seems like magic to a lot of people, but really what's behind it is the math. Math is what drives AI. And so today we're going to talk a little bit about how AI and humans are similar, how math is really the foundation for AI, and why humans still matter in this process. But since we are here for Pi Day, I just wanted to throw in a couple fun facts here about Pi Day. First of all, if you didn't know, Albert Einstein was born on Pi Day in 1879. The pi symbol was actually not started until the early 1700s. Not until, like I guess that was like 300 years ago. But and it was done by a Welsh mathematician, and it was actually the first Greek word in the word periphery. Pi was, and that's where he got that from. It didn't even catch on until later, but a couple other things. The record for number of digits was set in 2015 by a guy who memorized 70,000 digits of pi. And then if you ever want to see an interesting video, just recently, more recently than 2015, a young student in the UK set the record for memorizing the number of digits in 1 minute. And so here's a YouTube video that if you look him up, he's got a blindfold on and just reads off the digits straight through for a minute, 280 digits. So just a few fun facts about Pi Day, but circling back to artificial intelligence and why we're here today, I have a short activity to start us off here. Oh yeah, my background, you guys heard a lot about this already, but I did teach high school math and computers for 10 years. I did curriculum for 15 years. I'm going to talk a little bit about the end, but how I really got into AI was through my doctorate work here. I used it to help analyze qualitative data analysis. Yes, I'll explain why it was qualitative and not quantitative here in a bit. But I got to present at the University of Hawaii in Honolulu back in October of 2024 on the use of this. So that was a really fun experience and kind of set me into digging into AI more and its uses. But I have a short activity here just to get you talking about how this connects with AI. And so this first one will seem kind of simple and obvious, but that's okay. If I gave you this sentence, and don't yell it out right now, but if I gave you the sentence and said what word would go in there, what would your answer be? So most of you answered pi. Some of you may have been trying to trick the system, right? And that's okay. But most of you answered pi because what your human brain just did was make a prediction based on your past experiences, based on patterns you know, what was the most likely word. It's pi. And that's what AI does, is it makes a prediction. But if we do another one, in this second one, don't answer right away again. I'm actually going to have you think about it for a second because it's not as obvious. Math students at the University of Findlay are blank. So take 10 seconds, think in your brain what was the first word that jumped into your brain. And now I want you to take 30 seconds and talk to somebody next to you. What word did you come up with? What did they come up with? And see if they were similar. Go. All right, so in your talking, you may have come up with words such as smart, right? Or cool, or amazing, or the best. Or fun, or maybe even a few of you came up with nerds, right? It really depends on your context and your background and your experience. And that's similar to what AI does. It predicts words based on data it has learned, context, and patterns. And so in many ways, what you're doing when you're doing that is similar to what an AI tool does because they are just large prediction models. Although sometimes when they do these things quickly, they seem a little bit magical how quickly they can put this all together. And so to talk about how it's connected to AI, predicting the next word is exactly what large language models do. If you're talking to someone, sometimes when somebody says, like, what is AI and how does it create that, it can kind of be generalized down to being similar to your autocomplete on your phone, like predicting the next word, what you're going to type, times a billion. It's much more complex than that, but it's a prediction machine. And so AI predicts patterns. So when it does this, though, and because it can do it so quickly and so almost intuitively, it seems like magic. And so what this is actually called is the art of illusion, because of these 4 specific things. You know, it does it very fast. Any of you that have used any AI platform, whether it be a large language model or just even something embedded into a tool like, you know, predicting what you should buy from Amazon or things like that, it does it automatically for you, and it's quick. It uses human voice. The tone is very fluent, very confident. So the tone is a part of it. The versatility, the fact that you basically can have a conversation about anything with it, and it will give you answers about them. And then finally, the fact that it remembers, which is it makes you almost feel like you have a connection with it. You can have a conversation using any AI tool like ChatGPT or Gemini or whatever it may be, and then a week later come back and pick up the conversation just like you left off, and it still remembers that. And so all 4 of these parts together, psychologists actually call this the art of illusion, the illusion of understanding. It gives this illusion that it understands what it's talking about. So to think about this illusion and see what that means in action, a simple example of that is this. If I were to give a prompt to any AI chatbot and said something like, explain the probability to a 6th grader, at a 6th grade level, but make sure there's a reference to soccer. So it could give you something like this, where it gives you kind of a general definition of probability, and then it gives a nice example of a soccer player making 8 out of 10 goals, which means that the likelihood of them making the next shot is probably around 80%. Because that was all done instantaneously, it was quick, it was done in a way that it sounded very confident, it sounded very conversational. This sounds like something a teacher would say to you. It was well structured, and it comes back, like I said, instantaneously. And so when that happens, what that does is it gives the illusion that it understands what it's talking about. You know, what you saw on that slide there was a clear explanation, friendly language, instant response. It sounded like something a human teacher could say to you. But what you didn't really see behind the scenes was this. This is really what's happening. What's happening is there are thousands of probability calculations going on in the background. Words are predicted one at a time. Patterns are learned from massive data sets that it's been trained on. And then all these math models are working behind the scenes to do what? To predict. AI doesn't know the answer. It predicts what the most likely next word is. And so when we think about that, I just want to pull back the curtain a little bit here. And in doing that, you know, when you look at that answer again, the example that we just talked about, does AI know anything about soccer? No. Does it know anything about probability? Not like a teacher does. Does it know anything about language and how to present that? No. What it knows is what is the most likely next word. And then it just does that over and over and over, predicting what is the next most plausible word out there. And what is the foundation for all of those things? It's math. It's probability. That's what it's based on. So going back to our initial example we had at the very beginning, we talked about the fact that most of you answered pie for what is grandma most likely to bake a homemade apple blank, pie. And so this isn't the actual probability, this is just a sample chart here. But other words like tart could have been used. I heard somebody say dumpling. It could have been dessert, right? A homemade apple dessert. But is it likely that it's going to pick bicycle for that word? No, because the probability of that word is almost 0. So when AI is predicting these things, it's looking for what's the most likely next word. But the other thing I want you to keep in mind when you get output from an AI is that context matters. As we mentioned that, you know, what word you chose at the beginning for math students at University of Findlay are what? Probably depended on your context. Like if you're a math student here, you may likely have picked cool or smart or something like that. If you're a non-math person, those people may have picked nerds, right, as their perception, their context of math majors, math students. So if any of you have ever heard of when you're using an AI tool, it tells you that you should give it a role because you'll get better answers. Like you should say, I'm a college student working on this, or I'm a math professor trying to design a lesson for this. I want you to act as a math professor. If you give the AI a role, it changes the output, because what have you done? You've added an extra layer of context. Now the AI knows it's looking for those patterns, but patterns that are specifically tied to math professors or specifically tied to college students. So it's almost like adding a conditional probability, right? It's adding another layer that we have to look at when we're deciding what that probability of the most likely word is. So that's why you get better answers when you add a role to your prompt in AI, because you've now added more context to it and you've increased the probability of the words you're specifically looking for. So the same thing works with patterns. Obviously, we'll start out with a simple one here. If you start out with something like this, 2, 4, 6, 8, most of you would know the next number would be 10, right? But it also works with visuals. Like AI can recognize patterns in visuals just like we as humans can. This is a little more complex, right? If you had a little bit of time to think about this, you probably recognize that the shapes are alternating, but the colors are 3 patterns. Orange, black, white, orange, black, so you would assume the next shape would be white, and you would assume the next shape would be a square based on the pattern. So your brain was able to process that, work through that, and that's really what, again, the AI systems are doing, recognizing patterns, and that's what allows AI tools now to also replicate images and create images, because they recognize patterns based on all the other images and data that it has pulled together. It can pick up those patterns and then recreate them. So talking a little bit more about the math and thinking about putting something in and creating something out, this is the slide that I was probably most worried about including, and I'll explain why here in a second. So in general, before any of you math people jump on me, I'm just speaking in general here. In general, it's kind of working like a function. And I'll clarify here in a second. But your input is your prompt, so you're putting your prompt into the AI tool. And the AI tool has all these learned rules and patterns based on all the data that has been added to it. And then you generate an output, which is your generated response. So this is a nice way to generalize it and think about it. But anyone have an idea of why I would be concerned about putting this up here as a function, calling AI a function? What do you all know about functions? If you put in one input, what should you get from a function? One output, right? One input gives you one output in a function. And for any of you that have used AI, extensively, you know that you can put in the same input and get out a different output. It could be similar, but it could be different depending on the AI tool you're using. So before any of you send the math police on me, I know that AI is not a function, but it is a generalized way of thinking about putting an input in and then getting an output out of that. And that the middle part, which is not exactly a function, but it's this whole learned pattern of rules and data that it has. So that is kind of the basic idea. But there's another important piece to AI that a lot of people don't realize, and it ties in with math too. And this was something that I just learned at a conference about 2 years ago, and it kind of blew my mind is probably a little bit too high, but it was eye-opening to me, to say the least. And that AI has temperature. Has anybody heard of this? I'm just wondering if you've heard that AI has temperature. Okay, well good, because I was the same way when I went to this conference. And I was at this conference and the speaker's just talking about AI temperature, like we're all supposed to know about what he's talking about, and I'm like, I don't know what he's talking about. Finally, through context clues and further in his slides, I figured out what he was talking about. But does AI have temperature? Like, does it feel sick? No. What AI temperature is it's a setting, a math setting, that is put into the AI tool that determines what output you're going to get. And this is an important thing for you to know so that you know which tool you're using, what type of answers you're going to get. And so what I mean by this is if the AI has a high setting on temperature, And it's not something you can change. So it's not like you can go in and like adjust the temperature. You can't do that. It's set by the programmers, the developers. But if the tool you're using has a high setting, that means that there's more variability in the answers. AI that have high temperatures, if you put the same prompt in, those are ones that you're more likely to get different answers from when you get things back. Low setting is more predictable. It always uses the highest percentage probability word. And so these ones are more analytical. So it's important for you to know because, again, if you're doing something that's more research-based and you're looking for something that you want more analytical results, then this would be it. So to give you an example, and now I was actually digging into this more, but in general, they talk about the temperature being anywhere from 0 to 1. Now I've seen some of them recently go up to 2 and even beyond that. But if you get close to 0, then you're going to be more analytical. And so if any of you have ever heard of like perplexity is used a lot of times at higher education because it's like a 0.2. It's pretty low. And so it doesn't have as much creativity and variability. Some of the higher ones are like Gemini. Gemini's at 1.0. And that's the highest one of the common platforms. So just know that if you're a Gemini user, that's why maybe some of your results come back a little bit more creative, because that's how it's designed to be. If you're thinking about the math behind it, it allows lower probability, meaning like I'm going to circle back to our example of what was the word that you put in for math students. That one had more variability because it could have been smart, cool, fun, nerds, whatever. It wasn't as cut and dry as the apple pie one. So if you have an AI tool that has higher temperature, it may be variable and allowing you to say cool, smart, because they're all pretty close to each other, and it'll just pick one of them that's close. This leads also into, and I just like to say this, because we oftentimes talk about that AI has hallucinations. You may have heard this. People sometimes get frustrated because AI gives me a hallucination. And I just want to talk again about the math behind that, and that first of all, it's not a hallucination. When I dug into this more, the actual term, if you want to sound like you are super smart about this, it's a confabulation. A hallucination is meaning like something is out there that doesn't even exist. And that's not really what's happening. It's not just pulling some random word. Like, you know, on that first example I gave you with the grandma baking an apple, it's not going to pull in bicycle, just some random word there. No. What happens at times is AI, although it has tons of data, may not, again, it doesn't know anything. It's looking for what's a plausible word, what's a predictable word, and it puts something in there. The best example that I can relate this to when I was studying this is if your grandpa is telling a story from when he was in elementary school, he may not remember all the details. He remembers the main part of it, but his brain fills in the details that he's missing. He's not trying to lie to you. He's not trying to make something up. It's just that his brain doesn't remember all the parts, so it just fills in what he thinks. And that's what AI is doing. It's filling in with predictable words, but they may not be right, but they are plausible. And so that's what hallucinations really are. We refer to it as hallucinations. I think people say that because I personally, this is just me speaking on my beliefs, people use that word hallucinations because it kind of allows us to diminish AI a little bit. Like, look, it's not even that smart. It makes things up. But in reality, it's just using math to predict plausible words. The other thing about AI, like math, and like a lot of things we do, is it improves using optimization. And any of you that are athletes use this cycle all the time. Like something as simple as a basketball player learning how to shoot free throws. You may shoot 50 free throws at the end of practice, and hopefully you're not just sitting there shooting 50 free throws and not thinking about anything. No, you're thinking like, oh, it hit on the left side of the rim, so I need to move to the right a little bit. Or it was a little bit short, I need to shoot a little bit harder. Like, you're making adjustments based on your trial and error of doing those things to get better. And that's what AI does as well. It generates output, it measures the error. By measuring the error, it's always getting feedback from you. Notice how, if any of you use tools, there's always those little thumbs up, thumbs down signs. Like, did you like the output or not? If you click on one of those, it's giving it feedback to see if it was good or not. Sometimes, I don't know if you've come across when you're using different tools, it'll give you 2 outputs and say, like, which one do you like better? And then you have to choose. And it's then learning from that to know which type of format you like better. Or sometimes I simply tell it, like, you are wrong. Like, this is not the right answer. Like, this is what you should do. By you telling it that, it's always very polite to you, like, oh, thank you for letting me know. Then that helps adjust the math, adjust the formulas, adjust the patterns, adjust the data, so that it can try again and get better. So AI improves mathematically by minimizing the errors over time and getting better. One of the statements that I've heard, it's kind of funny to think about, but whatever AI you're using today is the worst AI you'll ever use. If you think about that. Whatever AI you're using today is the worst form of AI you'll ever use, because it's always going to get better every day. It's always going to have more data, more input, and so it's going to get more accurate as you go along. So where does this show up? Well, AI shows up in many different things, and we've talked about some of these. But you have tools like ChatGPT and Claude and Gemini and all those, and they could just be things where you answer questions and generate text for things. The recommendation systems, like we talked about earlier, that could be things like Netflix, Spotify, Amazon, any of that stuff. Any of your things that have feeds, like Facebook, Instagram, all those things, when you're doing that, it's based on algorithms from the data you've given it, even as simple as, pausing on your feed gives it data that you liked something. You don't have to click on anything. Just pausing on something adds to the algorithm that you liked that. And so that's how it knows then to suggest more content like that for you. Image generation, we talked about that a little bit ago. Now you can just create prompts and ask it to create an image for you. I was just part of, I was helping out at an event in Putnam County this past weekend where it was an art show. And that's one of the things they now struggle with. When they have guest judges come in to judge the best of show winners, the art teachers are always really adamant about making sure the judge is doing reverse image searches on the pictures just to make sure that the artist isn't just copying something from that they got off of the internet. Or now, though, if they used AI to help create something, there's really no way to necessarily check that against anything. So, those are things that they have to take into consideration when they're looking for judging them. And then search and writing tools. Just using it to summarize draft ideas, help clarify your tone for things. We're seeing this all over. And so I just want to give you a few examples of how I have used AI, just to get you maybe brainstorming or thinking of different ways. I mentioned at the very beginning I used this for my dissertation work. And so just to explain how this all started was when I was working on my dissertation, I wanted to do mixed methods because I was always a math guy, right? And so I've done quantitative stuff my whole entire career. And so I just wanted to push myself. Part of my getting my doctorate was wanting to learn. Again, probably why I would fall into the category maybe of being that nerd category. But I think that's important. I think as educators, we should always promote lifelong learning. And so when I did my dissertation, I wanted to do qualitative because I didn't know anything about it. So if you aren't familiar with qualitative data, it's anything that's not numeric, like text. So if you do an interview, how do you summarize that interview? If I interview 10 people or take open answer questions off of a survey, which is what I did. I had students and teachers answer a survey with open-ended questions, and then I had to analyze that data. Now I had math data too. Like I said, I had quantitative as well. But when it got to the point of analyzing qualitative data, and I was in my first qualitative analysis class, I was so naive on it that I truly expected that there was going to be a formula telling me how to code the qualitative data. And when they basically told me, you just pick out the words that you think are the most important, I was like, what? That's way too subjective. So when you're doing qualitative analysis, you're supposed to have a second person also read your stuff so that you're kind of comparing. Are we both picking out the same words that are important? And as a student, you don't have grad assistants or anything. So I went to my committee, on my doctorate committee, and said, can I use ChatGPT as kind of my second reader to kind of help me through this? And it was pretty new at the time because this was, again, we've only had AI around for a little over 3 years. And so would have been like the spring of 23, so it had just been released 6 months before that. And I said, can I use ChatGPT? And it was kind of like, I don't know, let's go down this path and see. So I had to be very transparent. I worked with my committee. I showed them what I was asking it, and really the professor I was working with said, like, everything that you're doing would be the same thing as you would ask a grad assistant. So you're just having these conversations. I wasn't having it do the work for me. What I was asking it was, are you finding the same patterns that I'm finding? Can you show me some examples of the things that you're picking out? Are they matching what I have? And so it allowed me to feel more validated that what I was doing was actually working. And then we could match that our patterns were. And I would have to push back on it sometimes. It found some things that I didn't like, and I pushed back on it. But that was why I started working on this, because I felt like I didn't have any experience in it. I needed somebody else to be my assistant, and that's what it really became. It became an assistant through my project. Also, the other thing that a lot of times people say, like, oh, AI is going to make us bad writers. And I would challenge you and say that if you aren't strong in writing, if you use AI in the right way, it can make you a stronger writer, because it models it for you, and you start seeing how it should be done. If any of you use Grammarly or even spell check, those are basic forms of AI too. And when I started using these tools like Grammarly and stuff, I started realizing that I write a lot in passive voice. Didn't even know that was a thing really, because I was not an ELA person. But I started realizing how I could write actively more in my voice. So you can use AI to be a good model for you to be a better writer. I have worked, as they said in my introduction, for the past 15 years as a curriculum coordinator, meaning I work directly with teachers, helping support them, analyzing data, doing professional development. And so I used it a lot to brainstorm ideas with teachers, like, how can I connect this lesson that you're doing, but connect it to some sort of authentic piece in your community? Make it more engaging. Any of the teachers in here, and any of you students probably have said at some point, like, why are we doing this lesson, right? Like, how can we make this more authentic and more meaningful? So using it to do that. Personalized strategies and ideas. Again, if you have a student, or even if for you, if you're struggling with a topic, but you connect to something else, like, hey, explain this topic to me, but using, again, soccer, or using whatever interests you, because maybe that will help make that connection. Explain this term with an analogy that's related to XYZ. And then maybe that connection will help make sense more to you. And so I've worked with a lot of teachers doing that. Educational leadership. I work a lot with principals and administrators, and now those are the classes that I teach are in the educational administration strand. So I use it to help them interpret data and provide individualized coaching and feedback. One of the things that I did was I evaluated a lot of teachers previously in my previous position. And for any of you that have, any of you are going to be teachers or know a teacher, like, the evaluation process can be pretty standard and not really helpful or useful. So I tried to make it more about coaching. And one of the cool, really fun examples I had one time was I was in a preschool classroom observing this teacher who was a phenomenal teacher. But I saw her on the side working with two students. And these two boys were just working on knowing their numbers. Again, these are preschoolers. And they were working on their teens and 20s. And the one boy was struggling because anytime he had the word like 15, he would say 50. If it was 17, he would say 70. So he was getting that mixed up. And the other boy was getting 10s and 20s mixed up. If it was 25, he'd say 15. If it was 17, he'd say 27. So me, I was just like, as a former math teacher, I was really like, what is going on in their brains to do this? Because I always taught high school, so I don't really ever have had any experience teaching the little kids like that. So I literally went back to my office to write up her evaluation, but I typed this one paragraph into AI saying exactly what I just told you. Two boys, they struggled with this, what's going on and how can we help them? And it was awesome because it explained like how they were mixing up the decades and the teens, and here's some strategies to do. So I shot those to her, and now I said, I don't know, you may do some of these, but if there's some of these can be helpful to you, that would be great. And she wrote back and she was like, oh, I do some of these, but there was like 2 or 3 ideas on there that were really good that I can use with these kids to try to help them stop that confusion that they had. So just little ideas like that to use AI. And then the other one too, for any of you, you're all college kids, you can role play scenarios in interviews. When I interviewed for this position last year at this time at Findlay, I literally put in my interview schedule and said, like, help me out. And it broke down the entire day, saying, here's when you're going to meet with these people. They could probably ask questions about this. This is what you should be prepared for. And then, if you don't know, a lot of the AI tools have voice, so you can just talk with them. And so I just had a conversation the one day with it, saying, like, walk me through the interview. Ask me questions. I answered. It gave me feedback on like, oh, you probably should highlight this a little bit more, but this was a really strong answer here. And so for any of you, as you're going out and looking for a job, use it to kind of go through and plan. Even if it's as simple as like, hey, I'm going to this job, what kind of questions they might ask me, or what should I prepare for? But you can really do a whole sample interview with ChatGPT or any AI tool and get feedback on it. So the one thing, though, that I did want to mention that, sorry, going back here a second, is that in each of these, the technology can help you immensely, but it's still the human that has to make the decision. And going back to this right here, this all started when I was working on my doctorate. And my chair of my dissertation said, you can only do this if you find research that says you can use this. And again, we haven't had a lot of time to have research on this yet, but there were several articles that have done research on this that says as long as the human is still the deciding factor and you're not relying on the AI tool to be the deciding factor, because the human knows the data better, the AI can analyze the patterns, but the human still knows the context better to make those decisions. So in any of these situations, it's still important to think about as far as keeping the human in the loop. Which leads us to our last couple slides here. Why does math still matter? Well, math helps us understand how AI works. You know, after hearing what I've talked about today, the past 30 minutes or so, about how AI can create all kinds of answers for you, it can create text for you, it can create entire reports for you, graphs for you, pictures for you. A lot of people think that math is less important. But I would argue that it's the opposite. Math has really become more important. And why? Again, it helps us understand how AI works. It helps us interpret those patterns in data. It helps us ask better questions. And just to preview the speech in the afternoon, is we're going to talk about asking better questions and questioning the output of AI, because that's super important to be a critical thinker in the world of AI. But it also helps us innovate new technologies. And most importantly, it teaches us success skills. You know, I mentioned this a little bit ago, that you probably, maybe yourself, have said this in one of your math classrooms, like, why are we learning this, right? How am I ever going to use this in my life? And I feel like math teachers get that more than anybody. Maybe I'm biased on that. But I think back to when I was teaching high school. I taught Algebra 2 all 10 years of my high school. I loved Algebra 2. I feel like Algebra 2 is like that time you start like putting all the pieces together, like understanding why it works. You're starting to move a little bit more from concrete to abstract. But you know, kids would always say, like, when am I going to use quadratic formulas, right? And there are some very practical things, like, you know, anything that's parabolic that it has made, it is important to know that. But I get that probably you're not just going to be asked out on the street someday, like, could you solve this using the quadratic formula? But what is important for math teachers and for math students to realize is you're learning so many important skills that are lifelong skills. Like, if you think about these 4 things that are up here: decomposing, algorithms, debugging, attending to precision. Decomposing, being able to take a math problem and break it down and figure out how to solve it, relates exactly to what any occupation you're going to be working in. You've got to be able to solve problems and break it down into solvable steps. Algorithms, can you come up with a process for how to, whether it's leading an initiative, whether you're working in a philanthropic group or some sort of, you know, a religious group that you're working with, or an employer. You know, we have an event, we have a problem that we have to solve. How do we have a process to do that? You come up with an algorithm. Debugging, one of the most important things. Can you think through how to fix something? Can you problem solve through it? Can you go back and say, this isn't working, like, how do we fix it? And then attend to precision. That's one of the Ohio math practice standards that I think is one of the most important and one of the most that's misinterpreted. When people read attend to precision, they actually, a lot of people think that means answering precisely, like rounding off to the right decimal point, or answering with the most reduced fraction. But really what attend to precision talks about, if you look at the essence of that standard, it's about communicating precisely. Can you precisely communicate what you're doing to somebody else? And that communication is one of the strongest, most important skills in any occupation you're going to have. So if you think about these 4 things, communication, problem solving, fixing, setting up a process to do an event or fix something, and then being able to break something down into pieces, those are things that you're learning in your math classrooms that can be applicable to any career that you go into. So when you say, like, when are we ever going to use this? It's those skills that you're going to use. It may not be that specific content, but it's the skills that you're learning. So, the other thing that's important too is that by doing all this and understanding how the AI works and how the technology works moves you from being passive users of the technology to people who truly understand it and can use it more effectively. But there is one thing that AI still cannot do the same that humans can do. If you think back at the beginning of this speech, when I gave you the grandma baking the pie analogy, most of you immediately recognized the pattern and came up with pie. And AI does something very similar. It predicts patterns and probability based on all the data it has. But there is a difference. AI predicts the next word. Humans choose what story to tell. Which leads us to our final thoughts here. And that is, artificial intelligence is amazing at recognizing patterns. It can create data, it can analyze data, it can generate text, it can generate images, graphs, all of those things in seconds. But innovation has always come from something uniquely human. And that is creativity, curiosity, and imagination. Those things are unique to humans. And so the math behind artificial intelligence is important, but it's our human ability to ask new questions and imagine new possibilities that really will drive the next breakthroughs. So, AI may help us explore patterns, but humans are still the ones who decide what to create next. So keep that in mind as you move forward. Any questions? All right. Thank you. Thank you again for having me here.